let's get on with it. I'm Gunnar Sletta. I have a master's degree in computer science from the University of Oslo. Actually, it's not a master's degree, it's a master's degree equivalent, because I didn't do master's back then. I worked with Qt since 2002, through Trolltech times, through Nokia times, through Ninja times for some time. And I'm still a contributor and maintainer of certain bits of Qt. My most noteworthy work is the Qt scene graph. That's the rendering engine that is responsible for rendering all of Qt and QML. And then in the long ago, I also did a large part of what is currently Qt Painter and Qt software rasterizing engine. So I mean, graphics is really, that's my area. I'm a freelance developer right now. When I say I'm working for Yolla, it's important to realize that I'm actually not employed by Yolla. I'm a freelance guy sitting in Bergen, and they just hire me on a regular basis. And the people that they hire that way, they call privateers. I mean, everything they do has something called has something named after the sea. Right? The employees are sailors. The CEO is a navigator, stuff like that. So, but I mean, it's they have a lot of people distributed around the world working for them, and they're all called privateers. So I'm a privateer, but I'm a freelance developer as well. So yeah. I mean, what I do for Yolla is mostly, again, on the graphics side. And I mean, I'll talk about Sailfish OS, but there's a slight tilt towards the graphics side of Sailfish OS because I mean, that's the part I know the best. And I mean, what I'm doing right now is that I'm working on this tablet and trying to make it run as fast as possible. So, Yolla. I have to sort of, the story of Sailfish is very parallel to the story of this company Yolla that made Sailfish. So I need to like do a little trip through the last couple of years to see like where we got to this place where we are now. So once upon a time, in the long ago again, there was a company called Nokia, and one of the projects that they had was a series of internet tablets. And in 2005, they released this Nokia M77 or 770, which was an internet tablet running Linux. Did anybody have that? Again, cool. Was that?
And 900 and 800 I had.
Yeah, I had this one, and this one is actually, this is actually mine that I took a picture of. And it had been lying in my drawer for the last 3 years now, and that's why like the M9 booted up and actually have a screen. This one was black because the display broke 2 years ago, and this one didn't boot at all, so that's why it's showing black. But anyway, this was Linux. There was a lot of open source bits in there. Very hackable device. Tinkerability very high. So there was a very enthusiastic community that formed around this operating system called Nemo. Now, I mean, there was other devices came out. The N900 was the first one to actually have a SIM slot. So it was like a bridge between a phone and a tablet. They still called it an internet tablet, I think, or a mobile tablet or something. It wasn't a phone, even though it was a phone. But I mean, it was a pretty nice series of devices. Then in around 2010, Intel came along and joined forces with Nokia. And Intel had their own mobile stack called Moblin. And the idea was that when two companies collide, they hope for synergy. So the idea was that they formed a merge Moblin with MIMO to form MeeGo. And this was a stack with a lot of ambition in it. They were going to run on TVs and in-vehicle entertainment systems and phones and tablets and everything. But it didn't go exactly like that. So a little while after they announced this partnership, and they were working on this phone already, the N9. But before that phone came out, Nokia's CEO, Stephen Elop, published this very nice letter to employees that has been known as the Burning Platform Memo. It's been published on every major tech site, so there's no secrets being spilled here. The document was leaked, so it's been also been brought up as an interesting study in how to not run a company, but that's besides the point. But I mean, in this Burning Platform Memo, the analogy is that Nokia's platforms, Symbian and Amigo, they were burning, and the only way for Nokia to survive was to jump into the icy cold waters below. And the icy cold waters below was Windows Phone. So basically, we dropped everything we do ourselves and we moved to Windows Phone. So I mean, so later that year, they finally got the phone out and it was released. But I mean, the platform was already dead, and there would not be any other devices. And needless to say, a lot of people were quite upset about this change. A lot of people lost their jobs, and I mean, the Amiga community was unhappy, and a lot of companies in the Amiga community was also unhappy. Personally, I was in the Qt organization at the time, and I mean, Nokia had been funding Qt heavily to sort of unify the App Store across all their platforms. But they didn't have any platforms anymore, so like, what did they need Qt for? Probably nothing. So that's then you are 150 people, and like, what are we doing here? And it's not so nice. But that's the Qt stories are different. Today we're talking about Yola. So just after the N9 was released, a couple of many of the Amigo team decided to, I mean, they were out of a job in Nokia, so they were let go. Now Nokia has this very nice concept called the Bridge program, and the Bridge program is that it's a severance package in a way, but it's a severance package that helps you build a startup. So it helps you be an entrepreneur, which again helps the local employments and everything. So it's a nice way to, like, you kick people out, but you give them a chance to start on their own on the outside. And I mean, all the guys, they accepted this, or many of them did, and together they formed Yola. Didn't really make much fuss about it at the time, but in October 2011 they did form Yola, and yeah, that's where the company started. All the former Amiga developers, at least many of them. I mean, Nokia retained all its patents, all its proprietary source code, so like the home screen, the applications, much of the middleware stack, all of that stuff Nokia sat on. But they did have the Amigo open source project, which is pretty much a mobile OS, and that's not a bad asset to start with if you're going to do a mobile OS. And of course, I mean, some of these guys have been in the Amigo team since, or the Maimo team since 2005. So I mean, they were fairly experienced in the mobile business as well. So they had a lot of know-how. Yeah, and interestingly enough, like Yola, it's pretty much the same word as in Norwegian, Yola, which is the tiny boat at the back of your bigger boat that you use to navigate to shore and everything. And as a joke on the Burning Platform Memo, instead of jumping into the icy cold waters, there's a small boat to save you, to take you to shore. So I think that's the primary reason for the name. So I mean, that's what happening. That is what happened on the inside of Nokia. But on the outside of Nokia, there was some other things happening, because there was a Amigo community, and a couple of things had happened, right? Nokia said we will ditch Amigo, and then later that year, Intel said, well, we're also going to ditch Amigo because we're going to team up with Samsung to do Tyson. So like, there they were, no father, no mother. Complete lack of control of this project that they loved. So two guys, Torsten Munk and David Greaves, sat down over the summer, and in like August or so they started publishing a lot of blogs about how they felt that the governance of this Amigo project should be. Like transparency, meritocratically, all the things that you typically find in a healthy open source project. And then they announced the new Amigo in 2011, 2011 October, roughly the same time as Yola was formed, and they called it the MER project. And MER is French for sea again, so it's in the same category. And I can't pronounce French, so I will say MER in French because that would sound weird. But yeah, the tagline for MER is that it's an open mobile optimized core distribution aimed at device manufacturers powered by Qt and QML and HTML5, openly developed, inclusive, and meritocratically developed. I mean, what it tries to really do is to be like an ultra-portable mobile stack for the same thing, tablets, phones, TVs, and everything. We did get actually Sailfish running on a television once, but the swipe UI feels a little bit awkward when you reach out to the television. And the television doesn't really have a touchscreen, I guess it's a little bit awkward. But anyway, so the MER project is like the foundation of the Sailfish. I said that Yola was found in 2011. They didn't say anything, they were actually quite quiet. But suddenly in the summer of 2012, half a year later or so, came this tweet along. Yola is here, Vigo-based smartphones will have a bright new future, stay tuned. So that's the splash they did for their company announcement. We are here, we're going to do stuff. Which is an interesting way to make your company known to the world. I mean, inside the Qt organization, we thought it was pretty cool because I mean, we had been left out to dry by Nokia, so nobody was really doing a Qt-based operating system anymore. And it's pretty cool if somebody did that. I mean, we had BlackBerry at the time, but BlackBerry only took a small part of Qt. They only took the core pieces, not the graphical pieces. And especially me being a graphics guy. They only take the pieces that were not the important pieces to me, they didn't really count. It doesn't mean that the BlackBerry isn't an awesome device, it just means that it doesn't use the parts of Qt that I'm passionate about. But Yola wanted to take the whole thing, Qt and QML and everything, so that was pretty cool. Shortly after they made that announcement, they also announced that they were partnering up with this company called ST Ericsson. Which was cool. They have the OS, they have a hardware partner, and they have been working on their own UI, and that's a pretty good setup. It looked pretty promising. Then a couple of months after that, ST Ericsson went out of business, went bankrupt, and then no more hardware. And as a manufacturer of a phone, that's a pretty tough situation to be in. And in addition to that, they went out to other manufacturers and they said, like, we have this Linux X11 based platform. Do you have hardware for that? And they were just like, huh? What? X11? Linux? What? We have an Android based layer. Yeah, it is really tough to get a hardware combination with like graphics chip and a SIM slot and all the right pieces together that runs anything other than Android. And the reason for that is of course simple, because everybody that builds a phone today builds an Android phone, so it's the only sensible choice if you're a hardware manufacturer to build an Android base layer. But this is where so they had some decisions to make and some clever hacking to do. So I mean, the Maemo stack was and Migo stack was Qt 4.8 based with X11. They had wanted to move to Qt 5. Qt 5 also came with Wayland support, and they knew that Wayland was at least possible with some of these base layers. So Robin Birchall and Karsten Munk, which were then both privateers for Yola at the time, sat down and spent a lot of time like basically getting the stuff running. Moving to Qt 5 and moving to Wayland. And they said that the following summer was completely ruined because of that. So, yeah. And then a while after that, they managed to release the phone. Running Sailfish OS, the continuation of the proper multitasking operating system, gesture-driven navigation, and the UI written from scratch by these guys. Marketing-wise, it also runs Android applications without Google Play services. So that's the device. And after the device launched, we tried to. This is pretty much when I joined. I joined like the month after the phone was released. That's when I started working with them. And they're aiming for monthly updates. So that's a time release every month. And we almost hit that target. We managed 12 updates now in the last 16, 17 months. So it's not completely on target, and summer is off anyway. But it's not completely on target, but at least pretty close. And the idea with the fast cycle is that when you're developing features, once the feature is done, you want to get it into the mainline as soon as possible. If the update cycle is long and your feature is almost done when you're approaching the deadline, you want to squeeze it in there. If the longer the update cycle is, the greater the chance that you destabilize and completely mess up the mainline when you're approaching the deadline, and the integration deadlines. So the idea was to have like a monthly update, and there will always be features that must go into a certain release, but for the majority of features, they can just you can work on them on the side, and then you can integrate once they're ready. And there has been quite a few nice updates, like 4G support came in, a software update, calendar sync came, new browser UI, performance improvements and stability and memory fixes and all sorts of stuff. So it's been working pretty nicely, I think. And then the tablet, as I mentioned, Indiegogo campaign. The idea was to raise about like $500,000, and it was funded by. It raised $500,000 in the first hour, and then it continued getting a bit more over the next couple of weeks and months. So it ended up at 480% funding of its original target, with some, I think it was like 20,000 funders, which is quite nice. And when it comes out later this year, it will have Sailfish OS 2.0, and then you can see it here afterwards. It's going to be.
You can claim that it has been, it's an exaggeration that it has been a success. But if you look to the numbers, how many works in Yola to make such a device? Do you know that? Or? Yeah.
Thank you for the question. Perfect timing. So I got this image. For the input framework. The UI technology is first and foremost Qt Quick, and a library on top of that called Silica that I will also briefly mention towards the end. There are two browser engines. How awesome is that? Two browser engines.
How many JavaScript engines?
Well, at least. The browser wouldn't necessarily have to run two at the same time in the same process, because it's a Qt Quick shell and a browser. I asked why we have two, and nobody really wants to answer, but I think that it's a simple answer that Memo and Migo used Firefox as the browser, I think, as far as I know at least.
It uses, at least Migo uses KubeCon.
Yes, but not before Qt was smacked into the stack, right?
And 9 is running a KubeCon browser.
Yes, that's true. But I think the N900 uses Firefox.
Yeah.
If I don't remember.
Yeah.
Yeah, and Qt comes with its own browser, and then of course somebody wants to use one thing, somebody prefers the other. And both of them have Qt Quick integrations, so there's really no reason to use one or the other. But the proper browser uses Gecko, and the email client uses WebKit. So it's two engines. And it's even better if you were to run QML test runner or something, the one that actually used to use Qt script, right? So then Yeah, the build environment Scratchbox 2 SDK is key creator based, but you can, it's just files, you can use whatever you like if you really want to. In the SDK there's also a VirtualBox based full simulation, full emulation of the entire machine with UI and everything, so you can play around with that. And the platform itself is built in OBS. Which is, it works fine for building a platform. It's not so nice when you need to do major changes across multiple libraries, but it works. And of course there's Perl. I have to mention that because it's a Perl conference. I have no idea if this is recent or old.
Recent-ish.
Recent enough.
It's 2012, yes.
Yeah.
It's pretty good for phones especially, but for Linux distros even.
Okay. Cool. I don't use Perl myself, so I can really say much about it. I think we use Perl for the packaging script of Jumbie, actually, the cute version of Java, for the first version. And then I get really upset, and then I rewrite template. Now that I've offended the audience, I can move on. Yeah. So, hardware rotations. That's the interesting bit, and that's the problematic bit with the STRX thing. The graphics side with X11 and everything, that's one problem, but there's a huge suite of stuff you need to think about. You need the ambient light sensor so that when it's dark in the room, you don't use too much backlight because that hurts your eyes. But you need to beef it all the way up when you're in the sunlight, otherwise you can't read the screen. You need a proximity sensor so that you don't accidentally call people and delete contacts and photos with your ear. Accelerometer you need to play video, you need to do audio, there's Bluetooth, Wi-Fi, all sorts of fun stuff you need to do. And on the graphics side, you need to be able to create rendering targets that you can put pixels into in one process, and then you need to share that with this windowing system process, the compositor, and how do you fit all those things together? And of course, when you get a hardware adaptation, you can often get a Linux stack. But the problem is that very often the APIs you need to do these things, they might be different standards, different extensions of APIs. There might be proprietary APIs you need to use. So it's certainly possible to do that, but it comes at a fairly high cost in terms of portability. At least until you managed all the varieties, and then it will be good. But there's a lot of work involved in adapting to a lot of different Linux base layers. But yeah, Android on the other side solves this problem. And of course, as I mentioned, everybody already provides an Android base layer. Drivers and kernel and everything. So it's the perfect thing to use. If you want to do that, if you want to do this buffer sharing, like Phil, you want to render in one process and display it in another process, they have an API called Graloc. Perfect. If you want to talk to sensors, vibration and LED control and all that kind of stuff, there's lib hardware. Bluetooth, well, there's Blues and Dbus and Bluedroid and everything. So there's stuff for everything there. So when you want to do portability across multiple hardwares, you need standardized APIs, and you need, on top of that, you also want to have stuff that is well tested and functional. And for a hardware manufacturer, because the Android stack runs on top of this, whenever you get any kind of prototype hardware, it will boot to Android, right? And it will work with Wi-Fi, it will work with USB, it will work with all those various things, because it's easy to test and verify that the software stack works and that the hardware actually and the drivers do what they need to do. So good quality hardware or good quality base layers are that's Android. The Android base layer is not. I can't speak for Android itself, but the base layer there is always very good. So ideally, what we want to use is we want to do the hardware adaptation of Android to build a device. But they're not quite compatible with the Linux stack. And you know which parts are problematic? or where it fails.
I thought it was the task manager or something, but
No, the problematic part is libc. So Android has uses Bionic, which has a different threading implementation, many things, it is like specifically incompatible with glibc. So you can't take a binary from one and run it in the other. It just doesn't work because things go bad. Well, I'll get to why it goes bad. But this is where the hybris comes in. So back in the time when ST Ericsson went bunk and you all didn't know what to do, Carsten Monk, he had been playing around with this concept for a while anyway, and like, is there a way for us to load an Android driver in our glibc environment, even though it uses Bionic? And that's what this library is. It's creating an environment where Android blobs feel at home. And I mean, it's a pretty neat read if you like C code and C++ code and are into like low-level linkers and stuff. Then it's a fantastic read. When he presented this at Foster last year, he said you're probably going to think it's a huge hack, but it works quite nicely. So yeah, it's on GitHub under libhybris if you want to look at it. So what this is that Bionic has its own dynamic linker. And the dynamic linker, what it's responsible for is that when it sees a library and a symbol that it needs from another library, like a function call, it opens that library and it resolves the symbol and finds the function pointer and puts that sort of into your code, into your library so you can call it. If you do that manually, you can do all sorts of tricks with it. And then you can tackle the problems that are there in most cases. And he said problems, as in like technical nightmares when they first happen, but I mean once they're solved, they're solved. So what libhybris does is that it opens like the binary driver, replaces all the function calls with proxies, and then like works around incompatibilities. So like thread local storage and pthread is quite nice. It's the implementation of threading is completely different. So if you were to be in a Bionic environment and we call pthread lock in EGL libc, then you would completely mess up your thread descriptor and like your program would crash with the weirdest errors. So like all the pthread calls on our proxy and with wrap and unwrap functions to make it work nicely. But there's the same problem with like float, with hard float versus soft float, because Bionic is compiled with soft float, which means that when you call a function that takes a floating point argument, that floating point argument is passed in an integer register in the CPU. But RStack is compiled with hard float, so we're passing those in the floating point register. So if you're calling from one place, you put it into the integer register, and the code that accepts that call picks it up from the floating point register. There will be crap there, and of course, the results won't be very nice. So again, for APIs that have floating point calls in them, there will be mangled and unmangled in these proxy functions in libhybris. So like OpenGL has a lot of proxy functions that unwraps and repacks variables between registers. And also, I mean, because the intention of this library is not to run Android, it's to run something else. So we don't need all of Android to really work. So as long as the drivers work, we're happy. So for some of these problems, there are a couple of patches to Bionic itself. So we don't take a stock base layer. We take a base layer with a slightly patched Bionic. And that's That's how it, yeah. I mean, that's how we then can use drivers. Really. Yeah, I thought I would just like quickly run through what it actually, how it actually does that. So if we think about like a game loop, can you actually read this very badly? So I mean, if we go down here, if I have a game loop and I want to draw stuff, the way that what you typically do is like you first need to create a surface, which is backed by a couple of buffers, like your double buffered or your triple buffered. You set up that surface to be rendered to, with a rendering context, for instance, and then you draw your stuff, and then you present the buffer that you rendered into, and then on the next frame you render into another buffer, and then you present that, and then you alternate like that. So a loop typically looks like this, like while animating my renderer, draw cute cats and dogs, EGL swap buffers. Anybody seen that kind of loop before? Yeah. Last of Us has certainly seen that kind of loop before. Prior to doing that, I would have to make this surface current, or then I make this context current. So I do a couple of like these EGL calls. And how these come to be is that, sorry. So we start by, we renamed the DL open function to the Android DL open so that we don't have a naming conflict for that. But we say open this lib egl.so, which is where like the proper EGL implementation lies. We need to resolve the functions, and of course these functions, there are no magic in them, there's no threading stuff, there's no floating point stuff, so they can just be proxies straight away. Initialize, display, get window surface, like set up display, initialize. And at some point, you get to this point where you create the window surface. And normally, when you create a window surface, you need to pass in some operating system specific, windowing specific handle that the driver knows how to deal with, which is like your surface, which is backed by these buffers and everything. And this is supposed to be an Android driver, and we don't have an alien windowing system because there's no Android running. So yeah, how to deal with that? And this is where it gets really fun. So I mean, normally if you write a game on Android, you would get that surface. I mean, what you need to pass in is the structure called a native window, and that's for Android native window, not a native window. I think it was a funny name anyway. But the way you would do that is that you would set up a surface, and then you would call into JNI, like from Java into C code, and you would say like a native window from surface, and you would pass in your Java surface. Perfect. However, we don't have the Java environment running, we don't have a window to get that from, so we need to dig a little bit further. And this is where in the Android open source project, if you go into include system window, you can see what this thing actually is. And it's actually just a plain old struct, a very simple structure. There's no magic in it at all. It has a couple of members like flags, ref count, DPI, and it has a couple of function pointers. Like BQ, whenever you want to start rendering and you want to give a buffer to the GPU, this hook BQ is called. And once that rendering is done, it calls Q. Sort of like Q that buffer to put it someplace. So that's okay. So it's just a structure. We can allocate that, populate it with a couple of functions of our own, and yeah, let's see what happens. And that actually works. I mean, you give that structure to the driver, it calls it back, and yeah, cool. But of course, what's that buffer going to be? Well, as it turns out, a native window buffer is also a structure in that exact same header file. So we just need to, it has width, height, format, stride, and a buffer handle. So we just need to like create that thing, and we're good. we have buffers and we can give them to the GPU. The GPU will give us back rasterized buffers that have been like completed on the GPU. And like this buffer handler is even nicer because it's, as I mentioned, this Gralloc API, which is how Android does. It manages the graphics memory across different units, like hardware compositor, like like GPU, CPU access, whatever you want to do with graphics, you can use a Gralloc buffer. Super nice. And this Gralloc buffer is really just, it's another simple structure that contains a list of file handles and a list of integers. And we have no idea whatsoever what those file descriptors are pointing to or what those integers mean, but they're visible to us, which means we can look at them and we can copy them, and we can copy them to a different process. So I mean, so then we can take this thing and we can share it to another process. I mean, this is exactly the same thing that Surface Flavor does as well, which is Android's compositor. So we know that it's the safe thing. I mean, it's a safe thing to do because it's what other people want once it's done. So how do we get that to screen somehow? Well, with Hybris in the EGL implementation, there's a small plugin system. So you can re-implement different types of a-native window hooks. Because I mean, if we change that queue function, the one that gives that buffer to someone, like presents it to something else, we can present it to different types of subsystems. If we just want to give it directly to the frame buffer, well then we just let queue send that buffer directly to the frame buffer device. Most hardware has a hardware compositor. Like in a television, you will have a picture stream. So that's one layer. And on top of that, you will have the UI. If you press the menu, there will come a UI, and you can see the picture stream below. So then you have two layers. The hardware compositor is a chip that can blend those in real time, very fast, without taxing your CPU or your GPU. So it's a nice additional resource when you want to do multiple layers of UI. That pretty much all modern UIs do. So if you want to post to that, well, there's a quick again API to do that. So you just post it to the hardware compositor. And perhaps the interesting one then is if we are in a client application and we want to post it to the compositor, well, we can, instead of posting it to an actual device, we can just take those file handles and those integers, we can pack them up and send them over WALAN to this other process, pick them up and draw it there in the compositor. And that's what the WALAN backend does. I mean, and then with those, we can typically, like the clients will use WALAN to send the buffer to the compositor, and the compositor will use either FBDev on the phone or hardware compositor on the tablet. So yeah, I mean that's Hybris, and that's the. It's a pretty nice library that does some pretty weird shit. I mean, yeah, I walked through the graphics side, and the graphics side is the biggest part of Hybris. But I mean, all the other things like the sensor APIs and all of that it's all proxied using the same techniques, and there are hooks to like work around these inconsistencies when they show up. And it sounds like a huge hack, but it works well in practice. Not unlike pretty much all other software.
So when you have Ali and Dalvik running on Sailfish, you're translating Android calls into Sailfish calls, and then using Hybris, you're translating those to Android calls back again?
Yeah, but in Dalvik is I actually don't know if they can go. No, they can't go straight to. No, there's probably multiple layers there. Yes, I haven't read the source before. Okay. Yes.
Okay, so how stable is this thinking of like future driver binaries?
Hmm?
So can this break, or can you guarantee that if I take some Android driver in the future from some vendor, that it will work? Or is there a chance that they are doing something which then breaks that using Hybris?
So the thing is that I mean you typically don't update the base layer, the hardware adaptation on the phone that often. And when we do, it's a very controlled process. So, and of course, we're free to patch hybris and fix those incompatibilities when they show up. And for sure, I mean, at this point, this library has been around for quite a long while. It's also used, I mean, this is how Ubuntu Touch also works. They're running hybris as well. WebOS is also running, OpenWebOS is also using this library.
And so that's why I'm asking, because of course, with hybris, this is not actually the well-known thing, and of course it comes up like in also Qt and the context from time to time that, you know, would this be an option on this and that board? But that's why I'm wondering that.
Yeah.
But there's a risk, right? Because we cannot guarantee that the given driver will just work.
So I mean, as I said, the idea is to make the Android blob feel at home, but it is not the Android blob, and it doesn't necessarily run with the exact same parameters as an Android middleware stack and system would run in. So it could be that there is a bug. Most likely it can be fixed by a patch to hybris, but I mean, it's not guaranteed that it's 100% like free, but it just works. And for sure, while porting Sailfish to other platforms, there have been a bunch of changes to hybris. So I mean, so it's yeah, porting to new hardware is typically, it will require something. But across, like typically across, I mean, many Android devices run certain families of Qualcomm chips, and as far as I know, the hybris works fairly well on most of those. So at some point you're fairly well covered, but of course, if there's a new hardware, sure. I'm pretty sure it's going to. You'll have to do some work.
I'll just ask another question on acceleration, because in the old days you just filled out the framework for kind of piece of like it's, if I understood this correctly, because I want to stay or asking the question, how does acceleration happen in this path where you go from
That's the DQ. The Windows surface, you have this hook called with the DQ, and then you create this buffer, which is most likely allocated in dedicated graphics memory, some special place of your shared memory. And the GPU gets that memory, it will rasterize it with whatever technique it has, and then it comes out afterwards, and you can post it to someplace else. So it's never in system memory anymore, but it gets done using these hooks and everything. So Frederick tells me my time is up. I didn't have that much more to. I had a couple of slides to.
It still take 5 more minutes or so, but I thought if we can,
On top of this, then we like have the Qt Wayland stack, which can do nice things. One nice thing which is quite unique with our compositor, which is also a bit of a problem, but it's nice for now, is that Qt Wayland can do composition of surfaces from clients, but it can also do QML in that same scene, which means that like our home screen is QML running live in the compositor process, and because this is then just Qt Quick that we can interleave with surfaces, we can put UI on top of Windows surfaces, and that's not a capability that, for instance, Android has. So like in this case, these are live covers. These covers, they are windows, so they're rendered in each of the applications, but we can put stuff on top of that, like these cover buttons, which lets you call actions and do stuff with those windows as they are live applications and everything. So it's a pretty nice setup altogether. I mentioned Sletta, the primary application toolkit. Quick and QML is everything on the platform from middleware and up is Qt based. Pretty much every single library and application and module on the phone links against something of Qt. So it's like an extremely central piece. And since there's Railgun support, you can pretty much connect any Railgun client as well. Like SDL support is done through raw Railgun. There, speed finish. Thank you.
Yeah, any questions? Thanks a lot. I think that was quite cool to get this inside view.
It'll
Things I didn't want to
it'll boot up in a little while. Come. So this is the partner space concept, which is this is just a mock-up though. But it's the idea is that you have this carousel. So if you, for instance, if this was an Amazon branded device, for instance, you would have like a special place in the home screen for the Amazon store, for instance. So this is just a mock-up, and just shows different views. And there's the event view where you have stuff that's going on, some controls, messages, and everything. You swipe from the bottom to bring up the apps, and once the apps are running, they show up here as these live covers again. To swipe them away, you take it away like that. So, yeah, that's the overall design of things.
Is this the final hardware, or will it going to change?
I think like the look of it is the
I'm just
final.
wondering because it looks a bit thick, but maybe.
Yeah,
I'm
it
wrong.
is. But that's the industrial design is the final one.
Oh,
But
okay.
but the build is not the final one.
Yeah, of course.
Does it have a second half?
No, not this one.
I noticed you mentioned you use eGLibC. What's the reason for that?
I couldn't tell you.
No.
I mean, probably that it's more suited for embedded.
I would expect that the answer to that question is we don't.
Huh?
I would expect the answer to be that either you're using an old GLibC or your slide is not up to date, because eGLibC is not a thing anymore.
Yeah, it got merged into.
You can merge back into GLibC.
They united again.
Aha.
Maybe your slide is just
That slide I took from content last year, so it's probably it could be that.
They have at least been merging over the last year or two after the German guy left Red Hat.
So